All right, let's dive right in. Today, we're going to break down a really fascinating technology called Sigfox. It's one of those things that's quietly connecting millions of devices all around us, and you might not even know it's there. So let's kick things off with a question, a bit of a puzzle, really. How on earth can a little sensor, maybe sitting out in the middle of a farm, send you data for years and years using just one tiny battery? Well, this is the core challenge of the Internet of Things, the IoT, and the answer we're looking at today is a technology called Sigfox. And that's exactly where Sigfox comes into play. It's what's known as a low-power wide area network, or LPWAN for short. Basically, it's a special kind of network that was built from the ground up to solve this very specific problem: long-range communication for countless devices that have almost no power to spare. So how does it actually pull this off? Well, the real genius of Sigfox is just how simple and elegant it is. The entire philosophy is built around sending tiny little bits of data, not very often, but over huge distances. It all boils down to this simple three-step dance. First, a device, say a sensor, wakes up for just a second and broadcasts a tiny packet of data. Then, any base stations in the area, and there could be several, pick up that signal and forward it to the Sigfox cloud. And finally, the cloud sorts it all out and delivers that little message right to your application. Think of it like a tiny digital postcard, short, sweet, and it gets where it needs to go. And this image here shows you exactly what that architecture looks like. It's called a star topology. Instead of some complicated web of connections, the device just, well, it shouts its message into the air. Any base station that hears it listens in. It's beautifully simple. The device just talks, and the network listens. Okay, now for the really interesting part. Let's get into the nitty-gritty, the actual numbers that make Sigfox what it is. And these figures are absolutely key to understanding both its incredible strengths and its very real limitations. First up, the message size. The maximum amount of data you can send is just 12 bytes. No, that is not a typo. It is ridiculously small, right? But that's the whole point. It's just enough for a temperature reading or a location or a quick "I'm okay" status. This small size is what makes it so efficient. Now, to get that incredible range and battery life, you have to slow things way, way down. We're talking a data rate of just 100 bits per second. Yeah, you are not streaming video on this thing. This is the absolute definition of slow and steady wins the race, because you're maximizing your range by minimizing your speed. So what does that slow speed get you? Range, a lot of it. Under ideal conditions, like out in the countryside, a single base station can hear a message from up to 40 kilometers away. Even in a city, you're still looking at around 10 kilometers. I mean, that is just massive coverage from one antenna. This table kind of puts it all together for us. A couple of things to really pay attention to here. That ultra-narrow bandwidth, just 100 hertz, which helps it cut through noise. And look at the huge difference between sending and receiving data. A device can send 140 messages a day up to the cloud, but it can only receive 4 messages down. This tells you the whole story. Sigfox is designed for devices that talk, not for ones that do a lot of listening. So with all these unique technical choices, what are the actual advantages? What do you get out of building a network this way? Well, it adds up to some pretty major benefits. It all comes down to one word: efficiency. Because the messages are so tiny and the radio is so simple, the energy use is crazy low. We're talking batteries that can last for years. That narrowband technology also means it can slice up the airwaves into tons of channels and is naturally more resistant to interference. And all of this put together means it's just cheaper to build and operate. But, and this is a big but, you don't get that kind of incredible efficiency for free. There are always trade-offs in wireless communication, and Sigfox makes some very deliberate ones. And this is super important to understand. Sigfox is not the right tool for every job. That super low data rate means you're obviously not sending big files or firmware updates. And since it's mostly a one-way street, you can't always guarantee your message was received. It also lacks some of the built-in heavy-duty security features you'd find on other networks, which is a major consideration for some applications. This chart just lays it out perfectly, doesn't it? Sigfox is fantastic for things like a simple alarm, tracking an asset across the country, or a smart meter that just needs to phone home once a day. But you are absolutely not going to use it for real-time control of a sensitive machine, streaming video, or processing secure credit card transactions. It's a specialist, not a generalist, and that is its true strength. So where do you actually see this highly specialized technology out there in the real world? Well, the applications are pretty much everywhere, often in places you wouldn't even think to look. You'll find Sigfox hiding in plain sight all over the place. Think about smart water meters that can suddenly send an alert if they detect a leak, or a home security sensor that can signal an intrusion even if a burglar cuts the power and the Wi-Fi. It's used to track shipping containers across continents, monitor the health of remote machinery, and even update the prices on those digital shelf tags you see in some stores. So, what's the big takeaway here? Sigfox is a powerful, elegant solution for a very specific problem. It does one thing exceptionally well, sending tiny messages over vast distances with almost no power. And in a world that's so often obsessed with big data and high speed, it's a fantastic reminder that sometimes the smallest, quietest messages can end up having the biggest impact of all.